Chemical reactions and equations. In our day-to-day life, we see different changes around us. Like if milk is left at room temperature during summer, it becomes sour and curdling takes place. If an iron tawa is exposed to moisture, it rusts. If grapes are fermented, they smell like alcohol. If food is cooked, its texture and taste changes. When food is digested, it is converted into useful nutrients. When we respire, food gets oxidized and releases heat and energy. In all these cases, the chemical nature of the initial substances is changed. These kind of changes are called chemical changes. A chemical change takes place due to a chemical reaction. Let us see some examples of chemical reactions in lab setup. When a magnesium ribbon is burnt in presence of oxygen, it burns with a dazzling white flame and white ash is obtained. This ash is magnesium oxide. When some potassium iodide solution is added to lead nitrate, an yellow precipitate is formed. This yellow precipitate is nothing but lead iodide. In the same way, when a few zinc granules are added to dilute HCl or H2SO4, hydrogen gas is evolved. Heat is also released in this reaction. In the above reactions, we observed change in state, change of color, evolution of gas, change in temperature. Along with change in chemical nature of the initial substance, we also observe any of these changes in a chemical reaction. So these observations help us to identify a chemical reaction. Chemical equation. Magnesium, when burnt in presence of oxygen, it produces magnesium oxide. This is the verbal description of a chemical reaction. This can be presented in the short form, that is in the form of a word equation. Magnesium plus oxygen gives rise to magnesium oxide. In this equation, the starting materials magnesium and oxygen are called reactants and the final substance formed magnesium oxide is the product. The reactants and products are separated by an arrow. This arrowhead points towards the products and shows the direction of the reaction. Reactants are always written on left hand side of the arrow and products are written on the right hand side. There is a plus sign between the two reactants and between the products. Writing a chemical equation using chemical formulas. Magnesium plus oxygen gives rise to magnesium oxide. Let us write this equation using chemical formulas. Mg for magnesium and O2 for oxygen. Mg plus O2 gives rise to MgO. Here the number of atoms on the left hand side and right hand side are not equal. That means this is an unbalanced equation. Such equations are called skeletal equations. Then how to balance a skeletal equation? Let's see. Balancing a chemical equation. The law of conservation of mass states that in a closed system, the mass of the reactants must equal with the mass of the products for any given chemical reaction. It implies that atoms are neither created nor destroyed in a chemical reaction, but they are rearranged to form different substances. That means the number of atoms of each element remains the same before and after a chemical reaction. So we need to balance a skeletal equation to present it properly. Fe plus H2O gives rise to Fe3O4 plus H2. Now let us balance this chemical equation. Step 1. When balancing a chemical equation, begin with enclosing each chemical formula within boxes. Do not change anything inside these boxes while working to balance the equation. Now tabulate the number of atoms of different elements present in this unbalanced equation. Iron, number of atoms in the reactants is 1 and in the products it is 3. Hydrogen, number of atoms in the reactants 2, in the products 2. Oxygen in the reactants 1 and in the products 4. Step 3. Sometimes it is easier to balance a chemical equation by focusing on the substance with maximum number of atoms. This substance could be on either side of the equation. For example, if we have Fe3O4, which has a lot of oxygen atoms. If we look at the oxygen atoms on both sides, there are 4 oxygen atoms on one side, that is on right hand side, and only 1 oxygen atom on the left hand side. So we'll start by adjusting the number of oxygen atoms to make them equal on both the sides. To balance the oxygen atoms, the number of oxygen atoms initial in reactants it is 1, that is in H2O, and in products 4, that is in Fe3O4. So to balance it, we will multiply the 1 with 4, 1 into 4 in the reactants. That means we are going to add 4 to the coefficient of H2O. So to equalize the number of atoms, we can put coefficient 4 as 4H2O. Now the number of oxygen atoms on both left hand side and right hand side are balanced. Step 4. Now balance the hydrogen atoms. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the right hand side. So atoms of hydrogen in reactants it is 8 in 4H2O, whereas in products it is only 2. So to balance it, in the products we are multiplying 2 with 4. That means we are adding 4 as the coefficient for hydrogen atoms. So now the equation becomes like this. Fe plus 4H2O gives rise to Fe3O4 plus 4H2. But still this is an unbalanced equation. Here iron is left unbalanced. To equalize iron, we take 3 atoms of Fe on the left hand side. Let's see. Atoms of iron initial in the reactants only 1, whereas in the products 3, Fe3O4. So now in the reactants we are multiplying 1 with 3. That means we are adding 3 as a coefficient for Fe. Now it becomes 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. So now this is a balanced equation. So step 6. Now count the number of atoms on both sides to check whether the number is balanced on both sides or not. This method of balancing is called hit and trail method. Step 7. Now writing the symbols of physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with the chemical formulae. The gaseous, liquid, aqueous and solid states of reactants and products are represented by the notations G for gases, L for liquid, AQ for aqueous and S for solids respectively. Aqueous is a solution in which water is the solvent. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, CO, G means gas plus 2H2, G that is gas gives rise to CH3OH, L that means it's liquid. And here on the arrow we can see 340 atm. It indicates the atmospheric pressure in this reaction. In the same way, in the next reaction 6CO2AQ that is aqueous plus 12H2OL that is liquid gives rise to C6H12O6 aqueous that is glucose plus 6O2 that is aqueous plus 6H2OL liquid. So this reaction takes place in presence of sunlight and chlorophyll. These things are mentioned on and below the arrow mark. It is to be noted that usually physical states are not included in a chemical equation unless it is necessary to specify them. Now let us find answers for these questions. Why should a magnesium ribbon be cleaned before burning in air? A magnesium ribbon should be cleaned before burning in air to remove the oxide layer that forms on its surface. This oxide layer, it inhibits the burning process. So, for a more vigorous, quick and complete reaction, this oxide layer should be cleaned with the help of a sandpaper before burning. Write the balanced equation for the following chemical reaction. Hydrogen plus chlorine gives rise to hydrogen chloride. First, let us write an unbalanced equation with the reactants and products. Hydrogen H2 plus chlorine Cl2 gives rise to hydrogen chloride HCl. But this equation is not balanced. On left hand side, we can see 2 hydrogen atoms and 2 chlorine atoms, whereas on right hand side in the product, only 1 hydrogen and 1 chlorine. So to balance this equation, we have to make that same number of atoms on both the sides. So the number of atoms of hydrogen and chlorine are to be balanced on both sides. Now, on the reactant side, there are 2 hydrogen atoms and 2 chlorine atoms. On the product side, each molecule of hydrogen chloride has 1 hydrogen atom and 1 chlorine atom. To balance the number of atoms, we need 2 molecules of HCl. So here we write 2 in front of the HCl. Now this equation is balanced. So this equation shows that 1 molecule of hydrogen gas reacts with 1 molecule of chlorine gas to produce 2 molecules of hydrogen chloride gas. Let's see the next one. Write the balanced equation for the following chemical reaction. Barium chloride plus aluminum sulfate gives rise to barium sulfate plus aluminum chloride. Now let us see the steps to write a balanced equation. First we write the unbalanced equation with reactants and products. BaCl2 barium chloride plus Al2SO4 thrice, that is aluminum sulfate. It gives rise to barium sulfate BaSO4 plus aluminum chloride AlCl3. First let us identify the number of atoms of each element on both sides of the equation and balance them. Let us tabulate them. Barium, number of atoms on left hand side 1, number of atoms on right hand side 1. So the barium is balanced on both sides. Next chlorine, number of atoms on left hand side 2 and right hand side 3. Aluminum, number of atoms on left hand side 2 and number of atoms on right hand side 1. Sulfate, left hand side 3 and right hand side 1. Let's start balancing with the compound that contains the most atoms, that is aluminum sulfate. Here there are 2 aluminum atoms on the reactant side in Al2SO4 thrice. We need 2 aluminum atoms on the product side. So we write 2 in front of AlCl3. Now aluminum is balanced on both the sides. Next, sulfate. There are 3 sulfate groups on the reactant side in Al2SO4 thrice, but only 1 sulfate group is found on the product side in barium sulfate. Now, add 3 before barium sulfate to balance the sulfate on both these sides. Now it becomes BaCl2 plus Al2SO4 thrice gives rise to 3BaSO4 plus 2AlCl3. Next, we have to balance the chlorine. There are 2 chlorine atoms on the reactant side. On the product side, we have 6 chlorine atoms. To balance it, add 3 before BaCl2. Now Cl2 is also balanced on both the sides. So this is the balanced equation. 3BaCl2 plus Al2SO4 thrice gives rise to 3BaSO4 plus 2AlCl3. This equation shows that 3 molecules of barium chloride react with 1 molecule of aluminum sulfate to produce 3 molecules of barium sulfate and 2 molecules of aluminum chloride. Types of chemical reactions. 1. Combination reaction. A combination reaction is a type of chemical reaction where 2 or more reactants combine to form a single product. Take some water in a beaker and add calcium oxide to it. Calcium oxide reacts with water vigorously and forms a precipitate, that is calcium hydroxide. Large amount of heat is also released in this reaction. In this reaction, 2 reactants, that is water and calcium oxide, reacts and forms a single product, that is calcium hydroxide. Such reactions are called as combination reactions. The chemical reaction in which 2 reactants react to form single product is called a combination reaction. Some examples of combination reactions are 1. Burning of coal. Carbon plus oxygen gives rise to carbon dioxide. So here 2 reactants combining together and forming a product, carbon dioxide. And second one, formation of water from H2 and O2. H2 plus O2 gives rise to 2H2O. Hydrogen plus oxygen gives rise to water. Here also 2 reactants, hydrogen and oxygen, are combining to form a product, water. So in this particular reaction, heat is also released out. The chemical reactions in which heat is released are called exothermic reactions. Some examples of exothermic reactions. 1. Burning of natural gas. CH4 plus 2O2 gives rise to CO2 plus 2H2O. In this reaction, heat is released. And one more example for exothermic reaction, cellular respiration. Here the glucose reacts with oxygen and gives carbon dioxide plus water plus energy. In this reaction also, heat is released. Decomposition reaction. A decomposition reaction is a type of chemical reaction in which a single compound breaks down into two or more simpler substances. Let us see some examples of it. Ferrous sulfate crystals are light green in color. On heating, the water in these crystals evaporates, resulting in the formation of an anhydrous ferrous sulfate. The color of the crystals changes from light green to white. Now this compound decomposes to different substances. They are ferric oxide, sulfur dioxide, and sulfur trioxide. Now let's see another example of decomposition reaction. On heating, calcium carbonate decomposes into calcium oxide and carbon dioxide. It is an important decomposition reaction used in various industries. Another example of decomposition. On heating lead nitrate, it decomposes to lead oxide, nitrogen oxide, and hydrogen. We can observe the evolution of nitrogen oxide as brown fumes. The decomposition reactions that takes place by heating are called thermal decomposition reactions. All the above discussed decomposition reactions are thermal decomposition reactions. Now let's see electrolytic decomposition. If the decomposition reaction takes place by passing electricity, such reaction is called electrolytic decomposition reaction. Example, electrolysis of water. The chemical equation for this reaction is 2H2O in presence of electricity, 2H2 plus O2. Now let us see photolytic decomposition. If the decomposition reaction takes place by the exposure to light is called photolytic decomposition. When silver chloride is exposed to sunlight, it decomposes into silver and chlorine gas. The chemical equation for this reaction is 2AgCl gives rise to 2Ag plus Cl2. Silver bromide also decomposes by sunlight. 2AgBr gives rise to 2Ag plus Br2 in presence of sunlight. The decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. The reactions in which energy is absorbed are known as endothermic reactions. Now let us learn about displacement reaction. Gather 3 iron nails and clean them by rubbing with sandpaper. Obtain 2 test tubes labeled as A and B. Pour approximately 10 ml of copper sulfate solution into each test tube. Securely tie 2 iron nails together with a thread and carefully immerse them into the copper sulfate solution in test tube B for 20 minutes. Set aside one nail for comparison later. After 20 minutes, remove the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solution in test tubes A and B. Also compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. The following chemical reaction takes place in this activity. Iron plus copper sulfate gives rise to iron sulfate plus copper. In this reaction, iron has displaced copper from the copper sulfate solution. Such a reaction is termed as a displacement reaction. Some other examples of displacement reactions. Zinc plus copper sulfate gives rise to zinc sulfate plus copper. Lead plus copper chloride gives rise to lead chloride plus copper. Since zinc and lead are more reactive than copper, they displace copper from their compounds. Now let us see double displacement reaction. A double displacement reaction is a type of chemical reaction where 2 compounds react by exchanging ions to form 2 new compounds. If we mix sodium sulfate and barium chloride solution, we get a white precipitate. In any chemical reaction, if a precipitate is formed, it's called a precipitation reaction. In this reaction, sodium chloride reacts with barium chloride and forms barium sulfate and sodium chloride. Here the barium sulfate forms the precipitate and the sodium chloride remains in the solution. Oxidation and reduction reactions. If a substance gains oxygen during reaction, then the substance is said to be oxidized, and such reaction is called an oxidation reaction. For example, when copper powder is heated in presence of oxygen, the brown colored surface of the copper powder turns black due to the formation of copper 2 oxide. So when copper reacts with oxygen, it forms copper oxide. Here, can we get back the copper from copper oxide? Yes, by a reduction reaction. If a substance loses oxygen during a reaction, it is said to be reduced, and such reaction is called a reduction reaction. When hydrogen gas is passed over heated copper oxide, the black surface coating undergoes a transformation, turning brown as the reverse reaction occurs, and finally copper is obtained. This reaction has both oxidation and reduction in it. Let's see, copper oxide turning to copper is a reduction reaction, whereas hydrogen turns to water, it is an oxidation reaction. During this reaction, copper oxide gets reduced by losing oxygen. The hydrogen is gaining oxygen and is being oxidized. So in other words, one reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called oxidation reduction reactions or simply redox reactions. Some other examples of redox reactions. Zinc oxide plus carbon gives rise to zinc plus carbon monoxide. In the same way, manganese oxide plus 4HCl gives rise to manganese chloride plus 2H2O plus Cl2. Now let's see the effects of oxidation reactions in our day-to-day life. Corrosion. When a metal is affected by substances around it, such as moisture, acids, etc., it is said to be corroded, and this process is called corrosion. When iron is exposed to moisture, it gets coated with a reddish-brown powder. This process is called as rusting of iron. The black coating on the silver articles and the green coating on the brass items are the examples of corrosion. Rancidity. When fats and oils are exposed to air, they get oxidized. This leads to change in their smell and taste. Then those fats are said to be rancid fats, and this process is called rancidity. To prevent the oxidation of fatty foods, the following preventive steps are followed. Adding antioxidant chemicals to the foods. 2. Keeping food in a tight container. 3. Filling the chips packets with nitrogen gas. This is all about the chemical reactions and equations. Thanks for watching. Please like the video. Please share this video with your friends. Please subscribe to Grade Booster channel. Press the bell icon to get all the latest updates. Check the description to find links of other useful videos.